All right, and welcome to space, everybody. It's the ultra early Sunday edition, and no time to screw around. We'll keep it as dense as we possibly can. Let's first look at the sun here in 304 angstroms, looking at the northern portion. And let's scroll down and let you see the rest. Active region, aka Sunspot 2755, has degraded to an alpha class sunspot, as we only see one polarity of leading umbra there. And we'll show you some high-res views in a minute. And here's a high-res view here. The intensity gram, we'll zoom way in to show you there's barely any umbra associated with that. It did not degrade as quickly as it looked like it was going to yesterday. But anyway, there's the date stamp for 7:15 Universal Time. And here's the view in 94 angstroms. And we'll just scroll down and let you see the any regions there. 94 angstroms does take 5 times as many images as all the other cameras except 131 angstroms. And there's the southern portion and that active region, Sunspot 2755, which is still considered a sunspot, folks. I expected it to decay to a plage yesterday, and it's taken its good old time as it moves into the Earth-facing area. Let's look at Helio Viewer real quick. And I just want to hit refresh to make sure we have the latest data for our viewers. And there you have Sunspot 2755, and let's fade that out to magnetogram so you can see the fields. And we'll slowly fade that down. And there you see the fields associated with that Sunspot 2755. Cycle 25 all day at a very high latitude, very close to the South Pole. And there are some coronal holes around that too. No big deal. Thanks everybody tuning in on Twitch. We appreciate you viewing the live stream. Now, if you haven't checked it out yet, check out smAsho.org. That's right, smAsho.org. It's a thing. Scroll down, click on the link to the forum. And if you haven't set up a login yet, check out the forum. Set up a login, you can post topics and talk about whatever you like. We put up a ton of articles yesterday about massive X-ray binary Cygnus X-3, as well as a lot of information about the liquid metallic hydrogen model of the sun. Shout out to Dr. Robitaille. Get back to me, Dr. Robitaille. We'll cover it on the channel if you'd like to make an appearance. GOES X-ray flux is pretty flatlined here, despite there being a sunspot. And the 10.7 centimeter radial flux has popped back up to 72 solar flux units, right around the orange line we've drawn in there at 70 solar flux units. KP index is back down to 1, having reached a maximum of 3 in the past 24, just before midnight. And we're going to look at cosmic rays real quick. We did see a spike here at Apatity on the 3rd. And that was some of the highest measurements, and that was the highest measurement in the past 30 days there at Apatity in terms of neutrons. Barentsburg not really sending data, so we see a tiny uptick there at Apatity and a small downturn at Barentsburg really over the past 30. Let's look at Athens, Greece. Were you aware that cosmic rays make it warmer at nighttime and colder in the daytime? That's right, folks. Cosmic rays make the planet warmer at night through the same mechanism that they make it colder in the day. Cloud formation. Cosmic rays cause clouds to form. Clouds in the daytime make it cooler via the albedo effect. Clouds at nighttime make it warmer via the greenhouse gas effect of water vapor. A real greenhouse gas, unlike CO2, which is not a pollutant. Some channels refer to it as plant food. A more accurate description than the climate control knob. Let's ignore that. Anyway, there's the last 30 days of neutron monitoring at Athens. And it's maybe a tiny uptick there, just a tiny uptick. Next, we'll look at Mexico City. And we always leave links to the Network of Cosmic Ray Station site so you can monitor these yourself. And we saw some big spikes here at Mexico City the same time we saw them at Barentsburg. Check it out. On the 3rd there, highest measurements at Mexico City in the past 30 days, hands down. Next, we'll look at Moscow. And Moscow still not sending data. They got some errors on their page there. And let's go to Oulu, Finland, and DOMC Antarctica. And you can see Oulu didn't really see the same spike, although around the same time. Really, they're at about a flat level there also over the past 30 days. And here's DOMC Antarctica. Again, we always link to the Network of Cosmic Ray Station site so you can monitor these yourself. If you see anything weird, drop us a line, smashomash@gmail.com. Here's a real-time solar wind data from the Discover. Very low solar wind density, 1.45 protons per cubic centimeter. Solar wind speed, 366 kilometers a second, having upticked starting right around midnight. And there's the data from ACE looking corroborative as it typically does. Something to understand, folks, is that the ACE is a little bit better shielded against cosmic rays despite being an older spacecraft. I don't know why. GOES electron flux is completely cratered. I mean, these are like some of the lowest levels we ever see. And not surprising, as we've had an extended period of extremely weak solar wind. Relativistic electrons are also at quite a low level, so expect your GPSs to be working okay even around the equator at noon. Here's the ionosphere movie. We're looking at 6 hours of the ionosphere here, courtesy Government of Australia Bureau of Meteorology. And we see continued anomalies in the South Pacific, almost as if they're moving farther south with time. These were closer to Hawaii a month ago, and now they're off the west coast of South America down there. You can see right there, we're seeing it charge up around 4 o'clock UT, 4:15 UT. Charges all the way up to 9 megahertz down there in the South Pacific. And we've been monitoring it for a solid 5 or 6 weeks on the channel. And let's move on to some more data after we look at the last image here. Here's the last frame, this one coming in at 7:45 UT. Another anomaly here on the prime meridian near Antarctica. And let's just move on. GOES magnetometer, there's the data from that. And we're seeing a rise of the magnetic strength as we make the video. And thanks to our new viewers, etc. Thanks for subscribing on YouTube. We appreciate it. Here's the Gong 2 data. This is 1 hour and 24 minutes old, and it's looking fairly steady here for the south-oriented portion of the current sheet, in which you likely reside, unless you're in space someplace besides on Earth. And you can see that red portion there is the South Pole-oriented portion. As the sun's south poloidal field charges up that portion of the heliospheric current sheet, we are approaching a polarity crossing here. Probably within the next 48 hours, we would not be surprised to see a current sheet crossing. As that sunspot moves away from the Earth-facing region, it will be perhaps decreasing the amount of time that it takes to get to that green section there, the North Pole-oriented portion of the current sheet, charged up by the sun's north poloidal field. Poloidal fields are the fields that come out of the poles, folks. And let's just move on here. To see the extremely weak magnetosphere, looking at 4 hours of data here, University of Michigan geospace model. Very low magnetohydrodynamic pressure. And we'll probably see this pop up a little bit right at the end. Maybe a little increase there in the last hour or two. Not really, as the solar wind is super weak. And let's look at the geospace ground magnetic perturbations here. And we're saying geospace delta B, folks. In other words, changes in the Earth's B field. That's the field that goes through a magnet, not to be confused with poloidal fields. Those are the fields that come out of the ends of the magnet, the magnetic poles. Anyway, the B field is the one on which you live. There's 4 hours of data from that. Not a lot of induced current during this magnetic excursion. Let's look at the last 24 hours of earthquakes. And I'm just going to slowly scroll up the list here. And we're only going to cover certain earthquakes of note, such as this 4.7, which struck yesterday at 1352 UT in northern Colombia there. That one at 162.3 kilometers and a 4.7 magnitude. Here's a weird one in Tennessee at 2.5 magnitude. Perhaps a frac quake, as there is quite a lot of oil production in Tennessee, I believe. And just continuing up the list here, here's a deep one near Redoubt Volcano. We've been seeing some deep quakes at Alaska. We've been seeing some shallow quakes, and when I say shallow, I mean thousands of meters above sea level at Hawaii, right underneath Mauna Loa. Here's a quake in Missouri. Here's another deep quake at Chile. That one at 102 kilometers and a 4.4 magnitude. We do see an earthquake there in Central Africa. We'll get to it in a minute. And is that one? That one's lower on the list. We actually passed it. The Democratic Republic of Congo sees a 4.5 magnitude quake. And let's get back to where we were here. Here's a 4.6 at extreme depth near Fiji, 519 kilometers. Deep quake at Japan. That one 107 kilometers depth at a 5.1 magnitude. No earthquakes over a 6 magnitude, but this one got close. And it is not good news for the area. Anyway, here's a 5.0 at Iceland, and here's that 5.8. That's the largest of the past 24. And that's a deep quake, folks, 5.8 magnitude at 97.2 kilometers. Heads up southern Mexico for a larger quake at the surface. And here's one coming in at 417 kilometers depth and a 4.3 magnitude near Sagave, Wallace, and Futuna. And last but not least, a 5.0 at Indonesia, coming in as we did show prep at a 5.0 magnitude, 206.5 kilometers depth there. Did you see our video yesterday? Well, we talked a little bit about evidence that Venus has active volcanoes. And this is basically doing mineralogical analysis. We didn't actually see the thing erupt, but chemical analysis showing the possibility of active volcanoes on Venus, yet another interesting feature. And let's talk about whatever volcano that is. It's Suwanisojima. No, it's not Suwanisojima. It's Shinmodake. So here's Mount Shinmodake. It's got another name that's even harder to pronounce. Just wanted to show you the location of this one. We'll zoom out here on windy.com. And there's a location of that. The webcam is not running right now. It looks like it was working 14 minutes ago. I don't think that one's looking at Shinmodake. It's probably too far away. Anyway, let's look at the pressure maps here on windy.com, as we do every day, to put some value-added services in the video. Anyway, we'll let that advance via the GFS forecast to about 24 hours from when we made the video, which was 3:04 a.m. Eastern Standard Time. And I'm back. Here's where things will be, according to the GFS forecast, at 12 Zulu tomorrow, at noon Universal Time tomorrow. Powerful anticyclone in the western U.S., as well as a strong low there southeast of Kamchatka. And let's move on here, as there's still plenty of stuff to cover. Today's volcano report includes Mount Aso, flight level 6,000 there. Suwanusei-jima in the Ryukyu Islands, 7,000-foot ash plume there. Mount Tokono exploding, flight level 7,000 there also. Kerinci in Sumatra, which I think we featured yesterday, exploding, flight level 15,000 there. Popocatépetl, looks like it's dispersed its volcanic ash, but there is still steam and gas emissions, so that could be fixing to explode once again. Popocatépetl, located very close to Mexico City. Sangay, which is in Ecuador, volcanic ash emissions still seen in satellite imagery. And Sabancaya, unable to detect. Please don't pitch a tent on the lower peaks of Sabancaya. Let's talk about the watchers. Shinmodake has had its alert level raised, and we left links to this article. The Japan Meteorological Agency has raised the alert level for Shinmodake, otherwise known as Kirishima-yama, from level 1 to level 2 on January 2nd. So if you're planning on doing some volcano tourism, please do not attempt to pole vault the caldera of Shinmodake. Links to that article shall be below the video. Truck spins out of control due to high winds in Wyoming. Check it out. AccuWeather coming through with the fresh video from somebody's dash cam. This truck goes flying. It's looking like a pretty slippery road. As the wind hits this thing from the right, it jackknifes, and then check this out, it just slides right off the road. Don't jackknife your truck. Be prepared for weather scenarios, and slow down if the road conditions are crap. Here's lightningmaps.org, and not a lot of lightning striking right now on a global basis. Check out lightningmaps.org if you hear thunder. It could save your bacon. Here's a nullschool.net jet streams, and they are screwed up in the eastern portion of the world. They are all over the place. Look at how odd these jet stream flows are. These are not normal jet stream flows, folks. Whether you're talking about the southern hemisphere or the north, we do not have anything resembling a coherent jet stream. As here's an area over north central Asia where the jet stream is moving east to west, the opposite direction from normal. And let's look at the Western world and move on here, as there's still lots of things to talk about, like Cygnus X-3. Anyway, there's the extreme meridional jet stream flow. Enough said about that. Let's look at the U.S. Doppler radar map. And some snow hitting western PA, as well as a bunch of rain hitting South Dakota. Rain on top of snow, and then it's going to get cold, and they're going to have an ice situation going on there. And man, oh man, lots and lots of snow. We won't get into it today. We'll look at the water vapor map, though. And there you have it. We're going to look at this convergence over Missouri, as it's looking interesting, as well as this anticyclone, which you see, as forecasted yesterday, all that wet air has been mopped up by this dry anticyclone, now north of Puerto Rico. Shout out to Peter Schiff if you're watching the video. And here's the area over the Iowa-Missouri border, as we see an interesting convergence happening there. And we try to pick one in the U.S. each day, as there's always some kind of weather happening. So there is that information. You see that swirling system there? It looks like a low-level low is has indeed created a pressure inversion there. And it's some suddenly violent weather, and if you're flying a plane across the U.S. today, expect some turbulence, as there are huge pressure gradients. Anyway, folks, if you're flying across Kansas, when you hit Missouri right now, you're going to see turbulence because the air is much denser, dry air, much denser than moist air due to the molar weight or molar mass, I'll say, of nitrogen versus water. And thanks to our patrons, we appreciate your continuing support. If you're not a patron yet, please consider becoming one, as we need lots more funding to not only continue what we do, but to reach our goals for 2020, such as filing our paperwork to get our nonprofit status, making your donations tax deductible. And thanks to everybody who subscribes, watches on YouTube, attends the live premieres, etc. Thanks, smAsho team. Literally everybody that views the videos. And welcome everybody to space and to the That Is an Ass and That Is a Hole in the Ground section, where we talk about everything from pack animals to sinkholes, and we remain vulgarity free, and we talk about whatever we want, such as fast things. What's the fastest thing ever built, you ask? At least as far as we know, the fastest thing ever built by mankind is that object right there, the Parker Solar Probe. And we'll be talking about it all year and for years to come, as it returns a bunch of crazy data about the sun, flies around at 250,000 miles per hour, and keeps getting closer and closer to the local yellow dwarf, sending back a bunch of data that a lot of folks didn't expect, and a lot of folks totally expected. Let's talk about some slow things. You want to know something that makes you slow? Snoring. We've left links to the experts' review of the 29 best anti-snoring mouthpieces in 2019. Now, most of these are mouthpieces, but there are also some other devices like a chin strap, nostril openers, as well as throat and nose drops and all kinds of different things. If you're snoring, you're not getting rest, as you're in a weird state of no deep sleep. So snoring will kill you. It'll take a long time. It's super bad for you, as it disrupts your sleep and your breathing and causes all kinds of issues. One of the issues is that if your jaw is too far back, you can put a mouthpiece in there that'll just keep your jaw forward, and that right there may prevent your snoring. So check that out if you're a snorer or if you know one. As we try to cover a few human health stories occasionally, please leave a comment if you think World War III's begun. And please leave a comment if you think cheaters are hilarious. Here's a cheater. It's Tom Brady. Bye, Patriots. Have a nice time riding the couch and watching the playoffs from a sofa instead of from the field. By the way, viewers, check it out. We are going to be releasing this shirt in January, is the expectation. We'll get a few of them and we'll sell them exclusively to our viewers, with first dibs for patrons. The 3C405 shirt featuring our URL to smAsho.org, as well as a radio image of Cygnus A, the second strongest radio source in the sky after only the sun, which is located about 500 million light years away. Here's the design in full res. And we made it black on purpose, folks. And let's don't get into it anymore, but look for the shirts coming soon, as we talk about space, another frontier. Let's head to the smAsho Mash cosmology segment, where we talk about things cosmology based. And we encourage you to be entropy busters. If you're wondering about this design, this is the galactic core of the Andromeda Galaxy, otherwise known as M31, where there appears to be a massive radio source, and they're being orbited by a series of very hot blue stars, as well as a bunch of stars that appear to have been ejected into a slower orbit. The Andromeda Galaxy core, a weird place, and perhaps we'll show you a video at a later time of what's going on in there. It's quite weird, and we can't look into our own galaxy's core because we are viewing it from the edge of the disk, and there's a lot of dust and gas obscuring Sagittarius A star, the massive radio source at the center of the Milky Way. Here's where stuff is in the solar system. Milky Way galaxy team for the win. There's where things will be in 1 week on the 12th. By the way, we talked all about Cygnus X-3, and we've put up tons of articles about Cygnus X-3. One of the explanations for the, shall I say, oddities in its extreme stellar wind is ionization, creating a small zone around this compact object, which apparently orbits this Wolf-Rayet star at a period of 4.8 hours. So let's don't even talk about what the tidal forces would be like. Let's just say if they were tides, they'd be high tides and very low tides. And here's where stuff isn't above my head. Here's where stuff is above my head. I think I forgot to refresh it. And there you go. There's where stuff is. And Cygnus is just rising. If you're wondering where Cygnus X-3 is in the sky, let me just animate this. Cygnus X-3, which rises at about 5 a.m. today, is the tail of the swan. Considered a very important star, Deneb is arguably the most intrinsically bright object in the entire Milky Way galaxy. It's at least the brightest object we can see. Cygnus X-3, a massive blue giant being orbited by an even apparently more massive radio source, and we're not going to get into the specifics of it. Let's just say blazars and their jets seem to be more and more important as time goes on. And if you viewed Cygnus X-3 from the side, it might look like this, as there is a very flattened disk, apparently, of all kinds of ionized gas and dust, and the chemical composition is very interesting. Here's the composite image of Cygnus X-3, and we're looking at the radio bands are the red and blue. The blue jet is the one facing toward you. This is the one that makes it into a blazar. And here's the red jet, which is facing away. The jet is emanating from this little white source right here underneath my pointer. That's where the little friend, the massive object orbiting the blue giant star, and then there's the blue giant star. One of the reasons I started studying X-3 is because of Göbekli Tepe, as Göbekli Tepe appears to be oriented toward Deneb, which is the other pole star at the other end of the precessional cycle. So right now the celestial North Pole is Polaris, and at the other end of the precessional cycle, Deneb is believed to be the other end of that. Is it a coincidence that Göbekli Tepe appears to be oriented toward that? Since 12,000 years ago, we believe Deneb was the celestial North Pole. Here's an artist's rendition of what Cygnus X-3 might look like if you viewed it a little more close up from the edge. And if you're wondering where you live out here in one of these jets about 20,000 light years away. And if you're wondering, Cygnus has been sending cosmic rays, physical particles, through your head, especially if you live in the northern hemisphere, for your entire life, as it circles the celestial pole, day in and day out. Here's another article about it. High-resolution spectroscopy of the X-ray photoionized wind in X-3 with the Chandra high-energy transmission grading spectrometer. That is in the smAsho forums. We will link it below the video here on YouTube also, if you're too lazy to sign up for the forums. Now, yesterday we talked about the infrared spectroscopic variability, and we put an article up about it, as this was yesterday morning's reading when I got up at 10 p.m. and read a lengthy paper about what's going on in X-3. That's one of the more interesting ones I've read. That's from the year 2000. Here's another one. We'll link that also. And there's the PDF for it. Your best bet is to look at smAshomash.com/forum to find that stuff. as we've compiled it all into one link. We've left the image of the M87 relativistic jet, as M87 has become very famous, and as time goes on, active galactic nuclei, blazar jets, and so on seem to be more and more important in terms of cosmology, the study of the structure and motion of objects in the universe, and perhaps even their origins. If you want to watch the transients from Cygnus X-3, check out the Neil Gorell Swift Bat telescope, and there are Cygnus's current transients, and it is actually in a quiescent state right now. And there are tons of telescopes trained in this object, always waiting for the next outburst, Cygnus X-3. Arguably the first discovered point source of cosmic rays. And it's all due to its 4.8-hour periodicity. That massive object is believed to be orbiting that Wolf-Rayet star at a periodicity of 4.8 hours. So if you don't think that's weird, I don't know what to tell you. But check out smAsho.org and our forum, and we'll talk all about it. Thanks again to our new viewers on YouTube, our old viewers on YouTube, etc. Please share on your social media, and please don't forget to take a moment to press like and subscribe, as the channel might be monetized for real eventually. Thanks again those viewing live on Twitch, which it looks like tumbleweeds. And last but not least, thanks again to our patrons, the real source of funding for the channel. Thanks, Smash Team, and stay tuned for some bonus features, as we've got a couple more things to talk about here. Let's get another image of Sunspot 2755's Umbra. There you have it. Not looking very dark. And again, I would expect this to evaporate throughout the day to a plage, as it certainly looked like it was weakening yesterday. Here's the latest image in colorized magnetogram. Let me move this over so you can see the date stamps. There you go. Shrink it down one level. There you go. There are the magnetic fields. And this is, again, degraded now to an alpha-class sunspot, as there's only one polarity that has umbrae. And let's break out the 171 angstroms view here, which we saved for the end. This is 48 hours of the local yellow dwarf. And we are out of here. Thanks again for tuning in, folks. There is an active region forming up here where my pointer is. Remember to stare at the sun. Use the proper instruments, like perhaps a solar filter or maybe the SDO. And when you're doing so, don't forget to not drink. And if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.
To see if they had an ancient object that resembled the Ark of the Covenant. They did convince the treasurer to show them the ancient crowns of Ethiopia made of gold, silver, and platinum, which dated back to the time of the Ark, but proved